We want to look at graphing with Excel. So you're going to start out with the data that was in the Word document for the Graphing with Excel lab. You can just take and cut and paste that table into your Excel plot. If you've got a Mac, there's obviously going to be a few details on that one. I'm going to leave that one up to you. But for right now, we want to take and graph these three columns. We always want the x-axis to be on the left of our columns. That's just how Excel works. So I'm going to take and I'm going to click and drag across the temperature, the vapor pressure of both chloroform and ethanol. I'm going to go up to Insert. I'm going to go to Charts, and I'm going to pick a scatter plot with no lines. It's going to give me this basic plot. Now, I am not going to ever add lines using the graph itself. I'm going to add them by hand in some manner. Make sure at this point you're going to take and you're going to put your axis titles in. So you're going to click on that add, otherwise it's an insert. And then here, we're going to want to add some trend lines. I would also advise at this stage putting in minor grid lines, both vertical and horizontal, just because it's easier to read a lot of the data if you do that. So once you have that done, you're going to want to put in a trend line for this. You can add it here when you do the chart elements, but it's by far easier to take and simply click on one of the data points. And if I right click on a data point, it is going to come up with add a trend line. If I do that, I'm going to recognize that first thing they're going to do, of course, is they're going to give me linear. I don't want linear, I want exponential. So they're going to change it to exponential. And then on your format trend line option, you're going to scroll down and you're going to display the equation on the chart. Displaying the equation on the chart is going to allow us to do math with that equation. And I'm going to do the exact same thing with the ethanol line. Right click on a data point, go to add a trend line, make sure it is exponential, not linear, so that it fits, and go down to display the equation on the chart. You can also add the R value if you like, so you can take and put the the point here to tell us how good the R squared value to how good our plot actually is. So that's certainly an option. And that's up to you on whether or not you're going to do that for your graph. Make sure you fill out your axes title, both for the Y and the X axis. If you've got a legend, my advice is to make it very, very, very small. Otherwise, it's going to take up a lot of the chart, which we never want. So you can always take and change the font on that so that it's much smaller. So you go to text options and make it a nice small font on your text. So that's my advice. Personally, I don't particularly like them, so I just delete the darn things and then my whole graph fills up. All right, so that's part one. Part two, we want the linear plots on this. This is the exponential form of the Clausius-Clapeyron. I'm going to take that data again. I'm just going to go to a different sheet on Excel, and I'm going to do this. Now, with the linear form of the Clausius-Clapeyron, we do not want the temperature in Celsius. We want on the x-axis 1 over the temperature in Kelvin. I always label my columns so that I know which axis I'm on. So I'm going to put 1 over temperature. I'm going to remind myself that that's in Kelvin. And to do that, I can do the math with Excel. So instead of taking and doing all the numbers by hand, we're going to let Excel do this. So if you take and you hit it equals, notice it comes up here in the function line as an equals. I want to do 1 over the temperature in Kelvin. So I'm going to take my 273.15. I'm going to make sure I'm going to add the parentheses there at the beginning, and then I'm going to add the contents of A2. So instead of putting the 5 in, I'm going to put A2 because that's going to allow me to do it for every single one of the cells. Once I've done that, typed in again, equals is required, 1 divided by open parentheses 273.15 plus the cell A2. I hit enter and I will get 1 over the temperature in Kelvin. If you take at that point and move your mouse, notice here it's like a hollow cross to the bottom right side of the cell, and then you left click and drag down, it will take the equation that's in that first cell and fill as you go down. That's going to give me 1 over the temperature in Kelvin. Now I'm going to do the natural log of the vapor pressure, and I'm going to do it for both the chloroform and the ethanol values. Natural log is a simple function here in Excel, and again, I'm just going to type in equals. ln is the natural log. I'm going to do a parenthesis because Excel requires that, and I'm going to put and click B2. I'm not going to put the number, just the cell location. Once I have done equals the natural log of B2, I'll hit enter. That's going to give me the numerical value. I'm going to move my mouse until the pointer is at the bottom right-hand corner of the cell, and I'm going to click and drag down. And I will fill each of these with the natural log of that space. I'm going to do the same thing for the ethanol and hit equals natural log. I'm going to pick C2 this time, end parentheses, hit an enter. I'm going to click and I'm going to move my mouse to the far right-hand corner and drag down. I am now going to have one of the temperature in Kelvin on the X, natural logs of the vapor pressure on the Y. I want to graph that, so I'm going to click and drag across. I'm going to do again, insert, chart. I'm not going to have them add the line. I'm going to do that by hand. And when I do that, I'm going to get my nice clean lines. I'm going to go to add and I'm going to insert my axis title right here. If I want grid lines, I'm going to do that as well and put them right here. And I'm going to get this. So we want to put in a trend line, our best fit line. To do this, we're going to right click on the data spot and we're going to add our trend line. This one is a linear function. If we plot one over temperature and the natural log of vapor pressure, we will have a linear graph. I'm going to put the equation on the chart because I'm going to need to do math with the equation. I'm going to shift it to the point where I can read it. And then I'm going to do the same thing with the data for the ethanol. Again, right click on a data point, click to add a trend line. Linear is what I want because this is a nice linear form of the Clausius-Clapeyron. Display the equation on the chart. Again, move it a little bit so I can read it. And at this point, I have the linear plots. Make sure you label your X and Y axes. At this point, if you need to mess around with your plot, you can. For example, there are plots where the x-axis is actually up top, and you can adjust that by actually right-clicking on one of the y data points and going down to Format Axis. If you do that, it changes or allows you to change the minimum and the maximum, and then more importantly, where the x-axis crosses at. I can make that variable. Right now, my x-axis crosses at 0. I could have it up top at 8. We do want it at the bottom of the column, though, or the bottom of the graph. So here, I have extra space in this. The data or the points between 0 and 2 are not used. So I can go here to my minimum and change that to a 2 and hit enter. And now my graph actually fits. The line itself actually fits as best as it can on this chart. So at this point, you have your graphs done.